Hello, everybody. We are talking about Unit 12.1 today, and that's the surface area of prisms and cylinders. So I've got I've got a cylinder here. Oh goodness, I just dropped it on my computer. It's just a can of tomato paste, but cylinders, the top and the bottom are circles, and we're going to show you how to find the surface area of this entire shape. So the top, the bottom, and then all this middle area in here. Prisms, they have a little more variation. So this is a rectangular prism, and it also has bases, and the bases are going to be triangles. So depending on what you select, which rectangles you select for the base, they're going to be opposite of each other. So if I choose like the top and bottom, the top of this Kleenex box and the bottom, then those would be the bases, and the rest of the area would be called the lateral area. That's a word you'll hear a lot today. I have another prism that looks like this. This is a triangular prism. And so instead of you having to choose the sides, you just find the two triangles. And those are the bases of this shape. So the triangles on top and bottom, front and back, however the picture looks, those would be the bases. The lateral area would be the three rectangle faces that are around the outside. I also have a hexagonal prism where it has hexagons for the bases. But this one is also a net where it will open up and it'll show you kind of the difference between the bases, this top and bottom, and then the lateral area, this area right here. Okay? So that's just a little overview of what prisms are. I'm going to switch over to our notes so we can get started. Okay, now that you guys have seen the shapes, we're going to jump over to the PowerPoint and talk about what we have going on with these formulas to find the surface area of them. We're going to start off, this is lateral area, which the LA stands for. And the way you find lateral area is by finding the perimeter of the base and then multiplying it by the height, which is how far apart the bases are. So this is kind of a visual down here. Here's my base on the top and the one on the bottom. They're the triangles in this particular shape because this is a triangular prism. And then what this lateral area is all of this blue area. So it's everything except the two triangles. So you need to take the perimeter, the length around the side, which would be this top line, the perimeter of the base, and then multiply it by how far apart the bases are, and then you have the area of this entire shape. And then, notice, the lateral area gives us everything except the area of the two bases. So that would make sense that surface area is just simply the lateral area, so the perimeter times the height, plus 2 times the area of the base. And I actually need to change this to the word prism. That is a mistake, and I will do that. But we're talking about prisms here, not pyramids. So the surface area, all it does is add the area of the two bases to the lateral area. Okay? And then I'm going to sneak over here. There we go. Now we're onto our formulas, and this kind of looks distorted, so I think I'm going to change what we have going on here on my picture. That's a little better. Okay, so this is the first example. It wants us to find the lateral area and the surface area for the figure. Remember, our lateral area formula was simply the perimeter of the base times the height. Okay, well, the first thing we have to do is figure out what the bases are. And so when you have a rectangular prism, the bases can, get a little bit confusing. Here is a hint. You're always going to use the top and the bottom rectangles as the bases. Okay, so I'm going to color these in with a highlighter. This is the top and the bottom rectangle. And those make up our bases. So we need to determine what is the perimeter and the height. Remember, the height is how far apart are the bases. So it's very important to know the height. You've got a base down here, a base up here. The height is just how far apart they are. So that's pretty easy to determine. It's just 3. And then you have this perimeter. Well, these are rectangles, so if it's 12 on this side, it's 12 on that side. Same thing for here, 6 and 6. So we just need to add that up together. So our perimeter is going to be 12 plus 6 plus 12 plus 6. So 12 plus 6 plus 12 plus 6. You're going to end up with 36 for the perimeter. So 36. So our lateral area would be 36 times 3. And that would give us the area of everything but the 2 shapes that I shaded in. So let me do this. 36 times 3, 108. Now we have our lateral area, and that's going to be centimeters squared. I'm going to go ahead and circle that. Some of your questions on your assignment will ask for lateral area only. Some will ask for the total surface area. And then if you remember the total surface area, that formula just adds let me write this out. Surface area just takes your lateral area, which is perimeter times height, and then adds 2 areas of the bases. So we need to determine what is the area of my base. We already know that our lateral area is 108, so we can plug that in. And then 2 times whatever we get for the base. Well, we need to figure out how to determine the base. We know that the base is a rectangle. How do I know that? Because I look at the shapes that I highlighted and realize, oh, that's a rectangle. And then I've got the area equals the base times the height. So we're just, this is where it can get kind of confusing. We're just looking at that shape down there at the bottom that we highlighted. So it's just going to be 12 times 6. We're not going to worry about that 3. So we're looking at that 2D shape that we highlighted, and we want the area of one of those. So 12 times 6, oops, is going to be 72. And that's what we plug in for our big B, or the area of our base. So I'm going to take 108 and I'm going to add it to 2 times 72. Now we get 252 for my total surface area. Centimeters squared. Okay. Awesome. Surface area equals 252 centimeters squared. And we have the lateral area and the surface area both. All right, let's move on to the next question. So here we have a prism, and then on the top and bottom we have hexagons. So if we notice, it's not a triangle, it's not a rectangle, trapezoid, it is a regular polygon. So we will eventually be using this 1/2 AP formula. I'm going to go ahead and draw in, this won't be perfect, but it'll be okay. So dotted lines for the shape of our, like the background of that, because it doesn't show it in this picture. And then what I'm doing is I'm highlighting the bases, just so you can see them a little better. So we've got a hexagon on the top and the bottom. And we need to figure out the perimeter of that base so that we can determine our lateral area. So the perimeter and the height are the 2 things that we need. So the perimeter, we've got, each side is 14. There's 6 sides. And we're going to get 84 for the perimeter. Our height, remember that's how far apart are the bases. Okay, I can't tell you how many people, use this height or use numbers located within the base, but the height is how far apart the bases are, so that's 25 units long. And we're ready to plug our numbers in. 84 times 25. So this is a pretty big shape, but if anything that's 25 units tall, and then this is 14 units wide, it's going to be a big shape. So we've got 2100 for the lateral area. And now we want to determine the total surface area. I'm going to circle that. And I'll write my total surface area formula. So it's really just the lateral area, the pH, plus 2 of the bases. Because the lateral area is everything but those 2 things that I colored in. So this is important now, because the area of our bases is going to give us our capital B. And we are going to use this 1/2 AP formula. The area of our base is 1/2 the apothem times the perimeter, which the cool thing is we already have the perimeter of the base. And then we have the apothem, so we can just plug those things in, which I will write them next to our problem so we are clear. 12.1 times 84. Times 12.1 times 0.5, or you could divide by 2. You get 508.2. We'll round to the nearest tenth. It's already rounded to the nearest tenth. So we take our lateral area, and then we add 2 of our bases. So I'll just take that number and multiply by 2, because that's the area of the base. And I'll add those to my lateral area formula, and we'll be done. Okay, and then that is the total surface area of this prism. Alright, last one. This one adds one more thing, but it's not difficult. We just don't have all the numbers that we need, so we have to do something to figure out what they are. So this is a triangular prism. There's triangles on each side, and those are going to be our bases that I highlight. Okay. All right, cool. So we need the perimeter of our base, but the problem is we have 3, we have 5, we don't know that length down there, but we can figure that out because these are right triangles. So we can use Pythagorean theorem to solve for that height, because we cannot figure out our lateral area without the perimeter, and we can't figure out the perimeter without this length. So I will use Pythagorean theorem, and this is a Pythagorean triple. So the more we do those, hopefully you guys are getting more comfortable with remembering these. It's a 3 blank 5 Pythagorean triple. So subtract 9 on both sides. And the length of this side is going to be 4. So there will be some homework problems like this where, it specifically asks for the length of that side first, and it'll be clearly marked. And then you'll have to determine the total surface area after that. All right, we are ready for our perimeter. So 3 plus 4 plus 5, and that's going to be 12. About to sneeze. And then we need the height, which remember is how far apart are the bases. So that's one reason I highlight that I've got a base over here, and they're 4 units apart. Okay? And so we can plug these things in, our 12 and our 4. 12 times 4 is going to be 48. So our lateral area is going to be 48 feet squared. Alright, now we have everything but the area of those two triangles. So now what we need is the triangle formula, which is right there. So surface area formula, pH plus 2 areas of the bases. What is my capital B? It is this lowercase b times height divided by 2. So the big B, the area of the base, is little b times height divided by 2. Remember, it's super important that the base and the height of the triangles are always perpendicular to each other. So don't get confused. You actually don't need this 5 except to solve for that base there. It's kind of just there to solve for that, and then you don't use it again. So, except in the perimeter. Okay, so you do use that, but you don't use it for the area of the base. You do 3 times 4 divided by 2, because they are perpendicular to each other, and it's the base and the height. 12 divided by 2 is 6, and that's the area of our little triangles over there. So my surface area is going to be 48 plus 2 times 6. So 48 plus 12. And I was like, yeah, I multiplied, so that's why it looks crazy. So it's going to be 60. Alright. And then that is my total surface area. Alright, movers. Okay. Lateral area of my cylinder. So it's everything but the 2 circles on the top and bottom. So it would be like on a can. It's just like you took the label off and you took the area of the label. So what it's going to be is, hopefully you recognize this 2 pi r. That is the circumference formula. So you're taking the circumference and multiplying it by the height. So it's pretty much the same thing as a prism, except instead of the perimeter, it's called the circumference. The height is still how far apart are the bases, and same thing, lateral area doesn't include the area of the bases. For this one, instead of putting big B, it's always going to be the same formula. So all we have to do is just plug in our area of the circle formula, which is pi r squared. Okay, let's move on to our examples. Alright, so the lateral area is going to be 2 pi r h, all multiplied together. No addition symbols or subtractions or anything. We just need to find our radius and our height, which is still how far apart are the bases, but on a cylinder you can say how far apart are the circles. Our radius is going to be 6 units long. Our height is 5. Our bases are the 2 circles. I can go ahead and shade those in. Getting better at shading. Oh, I spoke too soon. Went out of the lines a little bit there. So we are trying to find the outside, the label part. This one's kind of short and fat. It's kind of like a tuna can. So we have 2 pi r, so 6 times 5. Alright, all of these, we're going to leave our answers in terms of pi. So we are not going to put 3.14 in the calculator. We're just going to multiply the numbers, 2, 6, and 5. We get 60. We leave pi in our answer, and that's it. We're done. Meters squared. I know it looks weird. This is an exact number that you don't have to round, so it actually is a little bit easier. All right, so our surface area would be 2 pi r h plus 2 pi r squared. And we already have our lateral area. Oh goodness. So we've already done this 2 pi r h part. I'm just going to put 60 pi in there. And then here, all we're doing is using this area of a circle formula to find the area of the shaded part, multiplying it by 2 because there's 2 of them. So 60 pi plus 2 times 6 pi. So, sorry, 2 times 6 squared pi. Okay. So 2 times 6 squared is 72. So we have 60 pi plus 72 pi. This is just like adding 60x plus 72x. Just add the 60 and the 72, meaning you have 132 pi. And there it is, 132 pi meters squared. That's the area of a cylinder. All right, this last one, I'd like you to pause the video and work this one on your own. And then when you get done, you can come back and I'll work it. Okay, so we need 2 pi RH to find the lateral area. We have the diameter. We don't have the radius. So the diameter is 16. We've got to cut that in half to find the radius. The radius is 8 because it's half of 16. 10 is how far apart the bases are, or the height. 2 pi 8 times 10. I'll show the little multiplication through the dots. Alright, remember just multiplying the numbers, so the lateral area is 160 pi. My surface area, I'm actually going to write this a little bit different, as lateral area plus 2 times pi r squared. 2 areas of the bases. Surface area is going to be 160 pi, which I should probably circle that, meters squared, plus 2 times pi times 8 squared. Remember, only multiplying the numbers, not the pi. So 2 times 8 squared is 128. So 160 pi plus 128 pi equals 128 plus 160, 288 pi. It's a pretty big little shape right there. Okay, so that's all of the regular problems. We have one more advanced problem that we will do. Actually, we have 2 advanced problems to do, sorry. We need to figure out the surface area of this shape. So we don't include the parts that are covered up. Okay, so if you're looking at this, it's like you took a cylinder, cut it in half, and then put it directly on top of a prism. So we have to figure out what is covered up. We don't have the entire cylinder. But we do have one total circle, so I guess half of the bases, and then we have half of the lateral area. So we just have half of the surface area of a cylinder. So we need to find the total surface area, but then we need to cut it in half. So I'm going to write this out in words so it's less confusing. And then we need, so if our bases of this prism are the bottom and the top, let me draw this in. Not the best drawing. So our bases are down here. And right here. These are going to be the bases of this prism. What is the cylinder covering up? That's what you need to ask yourself. The cylinder is actually covering up one of the bases. So we would need the lateral area of the prism plus, so all this around here, because none of that's covered up, plus only one base, because this top base is covered up by the inside of that cylinder. So one base. I'm going to write prism base. I kind of ran out of room here. So one total surface area of the cylinder, and then divide it by 2. So cut that in half. And then you find the lateral area of the prism and only one base. Okay, let's do that. The surface area of my prism, the formula for that would be, we're going to multiply that by 1/2. Or sorry, my cylinder surface area, 2 pi r h plus 2 pi r squared. And we're going to take that whole thing and get an answer for that, and then cut it in half. Okay, so we'll go ahead and solve that so we don't mix too much together. We need our radius and we need our height. So this is 6 units long because this is a square prism, which any like rectangular or square prisms, you can kind of pick where the bases are because the bases just have to be perpendicular to each other. So you have 1/2 times 2 pi. Our radius is going to be half of 6. So if this is 6 units long, the radius is going to be 3 times my height. So how far apart are these two circles? They're 10 units apart. You can see that down here. And then we want to add the two bases, which eventually we're going to cut them in half. But we need to add them because we're finding the total surface area and then dividing the whole thing by 2. And then 3 squared. Okay, we have everything we need plugged in. So I'm going to take 2 times 3 times 10. I'm just going to do this first part first. So I've got 60 pi over here. I'm going to figure out this one. It's going to be 2 times 9 because that's 3 squared. It's going to be 18 pi. And then when we add those up together, we've got 78 pi. Okay, now we've completely determined that, and now we can cut it in half. So 78 divided by 2 is going to be 39 pi. And now we have half of the cylinder, so that part is done. Now we need to figure out the lateral area of the prism plus one base. So I'll write it out like that. So it's going to be perimeter times height plus the base. There's just one area of the base. Okay, what does that look like? What is the perimeter of this base? And I chose this one for the base. Okay. So the perimeter of that is 6 plus 10 plus 6 plus 10. So 32 for my perimeter. And then how far apart are the bases? It's easy to tell since they're highlighted. From yellow to yellow, it's 6 units long. And then the area of my base would be 6 times 10 because I have a rectangle. So I'm going to say 6 times 10 for the area of that base. All right, let's do this thing. 32 times 6 is 192. plus 60. So let's add those together, and we'll get 252. And oh my goodness, what is this crazy person doing? She's just circling it when it looks like that. Yeah, that's what we have to do, because if you are leaving answers in terms of pi, one of them has pi in it, one of them doesn't. You can't combine them. Okay, so the answers are going to be multiple choice, and they're going to look like this. This is as condensed down as you can get if you're leaving your answers in terms of pi. Okay, so that's what it's going to look like. And it's an exact answer. And we can move on. We're done. All right, this last one, I want to kind of show you. If I zoom this out, let's imagine this. Here's my prism. My Kleenex box. And then I put this on it. I put a cylinder on it. Just kind of like a picture. It's not, exactly drawn to scale. But I want you to think about this. What's being covered up when I put the cylinder on the Kleenex box? And you're probably like, a circle. Is it just one circle? So one circle on the cylinder is being covered up, but also one circle on this prism is being covered up, that same area. So it's really two bases that are being covered up. And I know you guys can see this base, and it's there, but it's actually covered up here and here. So we're not going to add the bases of our cylinder to this. It's going to maybe seem a little weird. So all we're adding is the lateral area of our cylinder, no bases, because one of the bases of the circles is covered up on the bottom of the cylinder, and then the other circle is covered up on the top of the prism. And then plus the total surface area of the prism. Okay. So it may take a second for you to understand, what's happening here. Okay, lateral area of the cylinder. It's just 2 pi r h. That's it, which is nice. My radius is 4. My height is 8. So 2 times pi times 4 times... Oh goodness, I meant to write 8 there. I think I can make it look like an 8. There we go. So 2 times 4 times 8 is 64. .64 pi is going to be the lateral area of the cylinder. Now we're ready for the entire surface area of the prism, because we've already taken away both things that are covered up. So we need the whole surface area. Okay, the bases are going to be the bottom and the top. There we go. We'll also, color in that base, why not? Alright, so perimeter of the base times height plus 2 times the area of the base. And then my base is just simply a rectangle. So when I highlight that formula, I'll use that. So perimeter of my base, 14 plus 8 plus 14 plus 8. I'm going to get 44. And then this height, and this height are going to be different. They're both h's, but one's dealing with the cylinder and one is dealing with the prism. So how far apart are the top and bottom base? They're 12 feet apart. So we're going to do 44 times 12 plus 2 times the area of the base is 14 and 8 are the two sides of the base. Now let's do all this stuff. 44 times 12 is 528. And then 2 times 14 times 8 is 224. We can just add those two together. 224 plus 528 is going to give us this big old number, 752. Alright, and that's it. I know that was kind of a long video. These are pretty tough problems. But that's all for surface area of